Good afternoon, dear students. You are welcome to the GMAETS 41's live stream class. We are going to be dealing with chemistry, right, in preparation for JAMB and WAEC. Although, even if we are looking at preparing for these examinations, the truth is that the aspect of chemistry we are treating is something that is also applicable to some other levels of learning, like advanced level. All right, students in SS1, SS2 can also benefit from this class, and so I am using this opportunity to welcome you all. All right, so this is 12:45 now. We shall be kicking off this class. You're welcome. So if you can hear me, you're in the class already. Please kindly indicate I can hear you so that I kick off the class right away. If you can hear me, indicate I can hear. Henry, you're welcome to the class. Joshua, you're welcome to the class. So please, if you can hear me, indicate I can hear. Then we kick off. Okay? Yes, I'm waiting for your response. No time, so that we can start off the class. Please, can you hear me? All right. John Paul, thank you for letting me know. So as usual, we've got these questions we want to treat. We are dealing with acid, base, and salt. Questions on acid, base, and salt. These are questions actually supplied by the GMAETS 41 student. I think questions from group 7 of our JAMB class. So we're going to look at these questions, and then so many more to deal with. So many more questions to tackle with from exam focus past questions, right? We'll be moving on straight to our first question here. We'll be moving on straight to our first question. Please take note, this is chemistry class. Let me indicate. And we are dealing with acids, bases, and salts. Remember, we are simply going to be giving answers to these questions. So our first question here, which one of the following is the strongest acid? Which one of the following is the strongest acid? Option A. Let's see, which one of the following is the strongest acid? I'm sorry. I don't know how come the thing just went off where I was. Okay. Which one of the following is the strongest acid? A. I'm going to write the options on the board. Okay. I'm going to write the options on the board so that you can see that this is question 1. We are looking for the strongest acid. Now the options we have there: A, we are given CH2Cl, COOH. B, we're given CH3COOH. C, we have, I don't know, I think what I have here is COOH2O. Okay, and then D, we have HCl. Now, which one of the acids given there is the strongest acid? The correct answer is option D. The strongest acid is hydrochloric acid as given there. Option A, B, and C, these guys are actually something organic related. And if you talk about organic acids are weak acids. Are you getting me right? They are what? Weak acids. Trying to figure out what this guy is. COOH. Trying to figure out what this compound is anyway, but it's of no use to us right away. The correct answer here is hydrochloric acid. Hydrochloric acid is a mineral acid. It's a strong acid. Now, when you talk about mineral acids, the following mineral acids are strong acids. We have hydrochloric acid. We have tetrasulfate 6 acid. we have trioxynitrate 5 acid. That's HCl, H2SO4, HNO3. We also have this guy also, it is strong in trioxophosphate 5 acid, H3PO4. H3PO4. So these guys are strong acids. Take note, given organic acids are generally considered to be weak acids. We are moving on to our second question. And the question reads, what acid is present in tamarind? What acid is present in tamarind? So we have this substance, tamarind. Which acid is present in it? Option A, citric acid. Option B, tartaric acid. Option C, dihydroxybutene acid. Option D, weak acid. I have problem with this question. I don't know the source where you got it from. Okay, I don't know the source where group 7 students you got it from. You are going to explain. Yeah, group 7. You're going to explain on Tuesday when I have you in the physical class. You're going to explain where you got these questions from. Reason is because of the options provided. Tamarind, we have tartaric acid in it. Now, that tartaric acid, actually, the name of that guy is dihydroxybutene acid. So, mycin tartaric acid and then dihydroxybutene acid. Right? It's just some kind of confusion there. Tamarind contains tartaric acid majorly. And that tartaric acid, you know, its component as per IUPAC, name to it, is a dihydroxybutene acid. So seeing those two options, B and C, I really don't know what much to say about it. We might still discuss about that further. Maybe when we meet, you tell me where you saw, you know, the source of this question and why these two options are presented. However, if I were to be in exam hall for this particular question, I will go for tartaric acid. All right? So that's the acid present in tamarind. We are moving on. So this particular question, okay, question 2. Question 2, I'm going to indicate tartaric acid or dihydroxy butene dioic acid. I really wasn't expecting those two options there. All right, but like I said, if you are seated in exam, at least to go for an option, I'll go with option B, which is tartaric acid. Question number 3. The salt formed from strong acid and a strong base. The salt formed from strong acid and strong base is the salt formed from strong acid and strong base is option A, complex. That's not the answer. Option B, neutral. That's what I feel. Option C, basic. That's not the answer. Option D, acid. That's not the answer. When a strong acid and a strong base reacts, the salt that is obtained from there is a neutral salt. Yeah, it's a neutral salt. So you want to take note of that. The reason, strong acid, strong base. Imagine that these two substances are fighting. Both of them are strong. And so no one is going to overpower. Therefore, the solution or the salt that is going to be produced in that case will be neutral salt. The solution, the aqueous solution of that salt will be neutral to litmus paper. All right, so the correct answer there is option B. Strong acid and strong base, when they react, they produce neutral salt. Option B. So question number 3. I'm going to use SA, strong acid, plus strong base, SB, is going to produce neutral salt. It's going to produce neutral salt. I hope this is not cutting off. Let me confirm that what I'm writing is showing on the screen towards the end. We are moving on. We are done with 3 questions. We are going on to the next question. All right. And Ekwe Chioma, you already supplied neutral salt. And that's correct. Okay, we are moving on to our next question. It's showing on the screen there. Question number 4. Question number 4. And the question reads, Arrhenius defined an acid as A species that can donate a proton. A species that can donate a proton. B, a species that can accept a proton. B, a species that can accept a proton. C, a source of hydroxide ion in water. A source of hydroxide ion in water. I don't have option D here. Group 7, I have a little issue with you guys. You know, even right from the one before you submitted this question, that's how it's been. One challenge to another one. Get serious next time you have opportunity to provide questions. Otherwise, you pay the penalty for not taking your work seriously. GMAETS 41, I've said this time and again, I don't joke with that. If I give an assignment, you had better work on it, right? Because I do my best to serve you guys. You want to also do your best to appreciate the effort of your parent. You can only do that by working hard, taking your studies seriously. If you're given assignment, work on your assignment. Now I have just 3 options here. I'm wondering where is option D, because of course we know sorts of questions mostly provide up to option D. All right, back to this anyway. Arrhenius defined an acid as what? The correct option here is option A. Right? According to Arrhenius, an acid is a species that can donate a proton. All right? So question number 4. Question number 4. Arrhenius' definition of acid. Arrhenius defined an acid as a substance that donates a proton. Good. And I said the correct option there is option what? A. Now I want to take note also, Arrhenius' definition of a base. According to Arrhenius, a base is a substance that donates hydroxide ion. That donates what? Hydroxide ion, OH negative. But this question is based on Arrhenius' definition of acid. According to Arrhenius, he defined an acid as a substance that donates a proton while in solution, okay? That proton can be written like this. Take note. That proton can be written either in this form. At least I use this one, you know, a lot to teach and explain this concept in our physical class, right? In our JAMB class, JAMB physical class, I used H positive. However, let me also tell you that it can also exist as H3O positive. Although this existence of proton in solution is not given by Arrhenius. It's not. So for that reason, I'm going to wipe it. But I just want to show you that H3O positive is also referring to the concept of hydrogen ion. Are you following, right? But the person, the scientist that proposed this existence of proton, that scientist is Brnsted-Lowry. So for now, since we are focusing on Arrhenius, I'm going to maintain this. But take note, like I said, H3O positive, right? It's also another form that hydrogen ion, a proton is considered to exist in solution. Okay, we are moving on. Question number 5 I have here. Which of the following in aqueous solution is neutral to litmus? Which of the following in aqueous solution is neutral to litmus? So what do we have there as options? Which of the following is neutral? Right? Which of the following solution, which of the following in aqueous solution is neutral to litmus? to litmus. Now I'm going to write the options provided. Question number 5. Question 5. These are the aqueous solutions given. We have option A, ammonium chloride. We have option B, sodium trioxocarbonate 4. We have C, iron 2 chloride. Then D, sodium chloride. And so the examiner asks, which one is neutral? Which one of the following aqueous solution is neutral to litmus? That is, will not affect litmus paper. If you bring red litmus paper, it won't change it to blue. If you bring blue litmus paper, it won't change it to red. Which one of these guys? The correct answer is option D. The correct answer is option D. Sodium chloride in solution will be neutral to litmus paper. Now you want to remember the reason for that. I explained all of this in our physical class. The reason is because sodium chloride is formed from a strong acid and a strong base. The strong base that produces sodium chloride is sodium hydroxide, caustic soda. The strong acid that produces sodium chloride is hydrochloric acid. So this sodium chloride you are seeing is a reaction between sodium hydroxide and hydrochloric acid. Both of the guys are strong base, strong acid. So the salt that is going to be formed, that salt, the aqueous solution of that salt won't affect litmus paper. It's going to be neutral. So the correct option there is that D. We move on to the next question. Question number 6. Meanwhile, if you have any question based on what has been explained so far, remember, feel free to ask. And as you join this class, what can you do? Share these links, okay? Share this link, the link to this class, to friends, okay? Don't share it to our group anymore. I've already shared it to our JAMB group. So all of the students there, they are aware that the class is already in progress. But you can share it to your friends who are in schools, are you following, right? Or others that are preparing for this professional examination, but maybe they don't have access to proper learning. Yeah, I don't know, maybe access to physical lessons. Yeah, share this link to them so that they can learn. All right, we are moving on. We are looking at question number 6. And listen to the question. It reads, the best treatment for a student who accidentally poured concentrated tetrosulfate. This question is funny. All right. I am going to provide my own already made answer to what I am saying, before I go for the correct answer. The best treatment for a student who accidentally poured concentrated tetraoxosulfate 6 acid on his skin in the laboratory is to wash his skin with, so what is the best treatment? Before I read out the options, the best treatment would be, I will ask the person, what it be your own? What were you doing that you had to pour concentrated tetrasulfate 6 on your skin? So that is going to be the first the first treatment. You didn't see any other thing to pour on your skin. It is tetrasulfate 6, But the person might not even live to testify to it. Okay? Let's move on. So where are we? So option A, cold water. Option B, sodium hydroxide solution. Option B, sodium hydroxide solution. Option C, iodine solution. Option D, sodium trioxocarbonate 4 solution. The correct answer is A, cold water. Okay, cold water. That's question 6. The correct answer is A, cold water. The reason is for the cold water to help dilute the concentrated nature of that acid. And you have to do that as fast as you can, yeah, as quickly as possible. Because if you don't, acids generally are corrosive. Tetrosis of its 6 is one of the strongest acids. Very dangerous when it comes in contact with the skin. So don't play. Don't play with that acid. If you find yourself in a laboratory, please make sure you obey the rules and regulations of the lab so you don't get yourself involved in an accident, laboratory accident, okay? All right, we are done with this. Now, before we move on to the next question, let me say this quickly. I didn't even remember to talk about it in class. But I had said something here, a bit related, but this particular thing I want to say now, I really didn't talk about it directly. Now, I said I mentioned something a bit about it because when I was trying to differentiate between strong acid and concentrated acid, then weak acid and dilute acid, because I said these terms are not the same thing. Sometimes we misplace concentrated acid to strong acid, they are not the same, okay? Or maybe weak acid to dilute acid, they are not the same. All right. The idea of whether something is concentrated or dilute depends on the amount of water molecule that you have in that acid or base, as the case might be, okay? Yeah. So if you add acid to water, that acid becomes, less in concentration. It gets diluted in the process. Now, what I want to say right away is this. You are not allowed to add water to acid. Rather, you add acid to water. You want to take note of this statement. Acid is added into water. You don't add water to acid. If you're adding water to acid, the concentration of the acid increases. Yeah, it increases. And it's very dangerous because the acid can splash. The acid can do what? Splash. Okay? So what is best as a practice is adding acid to water. All right, guys, we are moving on. Having said this, question number 7, we have this. It reads, which of the following acid is found in nettle plant? Which of the following acid is found in nettle plant? The acid found in nettle plant is formic acid. Formic acid. And that formic acid is also called methanoic acid. That formic acid is also called methanoic acid. So you want to take note of that, okay? So we have the options here. Option A, methanoic acid. Option B, citric acid. Option C, ethanoic acid. Option D, oxalic acid. The correct answer is methanoic acid. Now, methanoic acid, like I said, can also be called formic acid. Question number 7. We're talking about the acid that is present in nettle plant. Acid present in nettle plant. Is methanoic acid. The common name or old name, guys, is formic acid. Formic acid. Methanoic acid is the IUPAC name. So the correct option there is A. All right, we are moving on to the next question. Question number 8. Question number 8. If you have any question, you can ask your question. Okay. Let's see. A moment, please. All right. How are you? I was in a class. How are you doing? That's good. All right. This person, I don't know, I am saying AlCl3, aluminum chloride. Is that your name? I don't know if it is anhydrous or anhydride. Aluminum chloride. That's the name of the person there. Diluted means more water. Yeah, you're not wrong. That's part of what I also talked about. You have more water, all right, maybe acid in more volume of water, the acid gets much more diluted. So when you add acid to water, the concentration of the acid starts to reduce. The acid tends to become diluted. So you are still in line with what you said. Let's move on. I think we're moving on to question number 8 now. Question 8. Which among the following metal will not release hydrogen gas on reaction with dilute hydrochloric acid? Once again, which among the following metal will not release hydrogen gas on reaction with dilute hydrochloric acid? Option A, iron. Option B, zinc. Option C, copper. Option D, aluminium. Option E, none of the above. None of the above. The question is, which among the following metal will not release hydrogen gas on reaction with dilute hydrochloric acid? A is iron, B is zinc, C is copper, D is aluminium, E, all of the above. So the correct answer there is C. Copper will not release hydrogen gas from dilute acid. Question 8. So I said that the correct answer is what? Option C, which is copper. Now, what should you know about that? Why is it that copper cannot release hydrogen gas from a dilute acid? Why? Although we are here to treat electrolysis, okay, I think that's going to be our next class. Actually, I had already dropped one very important material for you guys. Yeah, what I put up about electrolysis, you know, the electrochemical cell, right? Did I put up that, or I think something like that? But anyway, what I want to talk about is that in electrolysis, there is a series we call electrochemical series. Electrochemical series. That series, you have arrangement of cations. Okay, I think the first guy there is potassium, followed by sodium, and then in that order, you have calcium and the rest. Now, that series continues going down, going down. You will meet hydrogen before copper. Just after hydrogen, below hydrogen, you will see copper, which means that hydrogen is above copper in that series. It is called electrochemical series or activity series. Hydrogen is higher than copper in that series. Hydrogen is a senior to copper. And because hydrogen is above copper in that series, it means that copper cannot displace, cannot remove hydrogen from dilute acid, because hydrogen is above copper. Generally speaking, as a rule of thumb, metals that are above hydrogen, metals that are above hydrogen in that series, they will remove hydrogen, they will release hydrogen from, solution. For example, like this dilute acid now. Any metal that is higher than hydrogen in that series, that is senior to hydrogen in that series, that is above hydrogen in that series, will release hydrogen from an acid, right? So that's the rule. But in this case, copper, like I said, is below hydrogen. Therefore, copper cannot release hydrogen from that dilute acid. I hope that makes sense, right? That's why the correct answer is option C, copper. All right, we are moving on. We are moving on. Take a moment with what you have there. so that we move to the next question. Sorry, trying to ensure that the electrical connections are intact. All right, we are moving on to the next question. Question number 9. Okay, so question 9, we have this iterate. See what the question is. What's happening here? This disappears a lot. Okay, so I've got it. Question number 9 reads, color of phenolphthalein indicator. Color of phenolphthalein indicator in alkaline medium is, so it's much like what is the color of phenolphthalein in alkaline medium. You know, phenolphthalein is an indicator used during titration process. So what is the color of that guy in alkaline medium? The answer is pink. Option A is white. Option B, pink. Option C, yellow. D, light green. E, none of the above. The correct answer is pink. Question number 9. Then pink is option what here? B. So phenolphthalein is pink in alkaline. You can also refer to it in basic medium. In alkaline medium. So the options given, option B is the correct answer. Phenolphthalein is pink in alkaline medium. Now I'd like you to find out what is the color of phenolphthalein in acidic medium. Color of phenolphthalein in what? Acidic medium. You can drop your answer in the comment box if you have it, okay? I'd like you to find out. Because you have this question, you can also be asked the color of phenolphthalein in acidic medium. So I'm giving it to you as a quick classwork. If you have the answer, like I said, drop it in the comment section. Let us move on to our next question, number 10. And I guess I'm going to wipe off this part of the board to move on to question 10. All right, so is a patience colorless, Henry Magabuchi colorless, Imaginate colorless. That's correct. You guys got it correctly. Are you following? Phenolphthalein in acidic medium is colorless. All right, so that was a quick one from you guys, and it's wonderful. Question number 10. The reaction between ethanoic acid and sodium hydroxide. The reaction between ethanoic acid and sodium hydroxide is an example of A, esterification, B, neutralization, C, hydroxylation, D, hydrolysis. So that is a neutralization reaction, because of course ethanoic acid is an acid. Even though it is weak, it's an organic acid, and sodium hydroxide is a base. So the reaction between ethanoic acid and sodium hydroxide is still the same as the reaction between acid and base. And when acid and base react, the name of that reaction is what? Neutralization reaction. So question number 10 is B, neutralization reaction. That is when sodium hydroxide reacting. If I am to show the reaction equation is something of this kind, this is ethanoic acid plus sodium hydroxide. Now during the reaction, the ethanoic acid will release its ionizable hydrogen ion, which is that hydrogen there. The basicity is 1, which is the basic strength of this acid. Then sodium hydroxide will split here, and you now have the product in the form. Sodium, which is positive, will react with the negative carboxylate ion. CH3COO negative is carboxylate ion. And we're going to get CH3COO-Na. This is sodium ethanoate. Sodium ethanoate. Then this hydrogen will combine with oxygen, with OH hydroxyl here to give you water. So this is neutralization reaction. We are moving on. Question number 11, still the same as that question 6 or so. The best treatment for a student who accidentally poured concentrated tetrasulfate 6 acid on his skin in the laboratory, blah, 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 blah. Group 7. Did you not see that this question you had already written it? So why repeat it again? I'll come for you people. Huh? The people stressed me before dropping these questions. You stressed me. And now, all these 1, 2 silly mistakes. All right, let us move on. We are going to jump down question 11. We've mentioned that you need to immediately pour cold water, right, on the person in order to wash off that part of the skin. So we are moving on to question 12 as we have here. The acid anhydride. The acid anhydride that will produce weak acid in water is the acid anhydride that will produce weak acid in water is, now these are the options we have. I'm going to write out the options. Please, this is question 12. We've already answered 11. So the acid anhydride that will produce weak acid in water is option A, we have SO3. That is not the answer. Option B, we have NO2. That is not the answer. Option C, we have SO2. That is not the answer. Option D, we have CO2. That is the answer. These guys are called acid anhydrides. Why do we call them acid anhydrides? They are called acid anhydrides because when you dissolve them in water, they will produce acid solution. When you dissolve them in water, they will produce acid solution. I had already defined acid anhydride in our physical class for your friends who are in GMAETS 41's JAMB physical lesson, all right? And I told you that acid anhydrides are gases usually from, you know, those ones containing oxygen. Yeah, those ones containing oxygen. But something like chlorine can also be considered as acid anhydride as well. So because if it dissolves in water, you know, produce a hydrogen chloride, which is a bit acidic. So what's the point? Acid anhydride, these are substances which if you dissolve them in water, they will produce acid solution. So the question now is, which of these ones will produce a weak acid? It is CO2. If you dissolve CO2 in water, you are going to produce carbonic acid. Carbonic acid, hydrogen trioxocarbonate 4. Trioxocarbonate 4 acid. Something of this kind, CO2 plus H2O. And then you get something like H2CO3. This guy is a weak acid. Is a weak what? Acid. One of the known weak mineral acids. Okay? Yeah, one of the well-known weak mineral acids. So this will produce strong acid. I think this will tend to tetrasulfate 6. This one will tend to triosonitrate 5 acid. This SO2, if you dissolve it, it also tends to the trioxo and tetrasulfate 6 acid groups. And then, of course, carbon dioxide will give you the carbonic acid, which is weak. So we are done with that. We are moving on to question number 13. Question number 13. And that question number 13 reads, which of the following salts is slightly soluble in water? Which of the following salts is slightly soluble in water? Question 13, the options we have: A, we have silver chloride. This is not the guy. B, we have calcium tetraoxosulfate 6. C, we have sodium trioxocarbonate 4. D, we have lead chloride. Lead chloride. So we are being asked which of them is slightly soluble in water. Which of these guys is slightly soluble in water? Calcium sulfate. Calcium sulfate, slightly soluble. This is insoluble, this is insoluble. This guy is soluble in water. Then this is slightly soluble in water. Now this takes us to question number 14. Question 14, we have the basicity of tetraoxosulfate 6. The basicity of tetraoxosulfate 6 is A, 7, B, 5, C, 4, D, 3. Sadly, the correct option is not there. Basicity of tetraoxosulfate 6. Option A, 7. That's not the answer. Option B, 5. That's not the answer. Option C, 4. That's not the answer. Option D, 3. That is not the answer. So I don't know. The basicity of tetraoxosulfate 6 is 2. Question 14. Basicity of tetraoxosulfate 6. I think I spelled that well, right? Basicity of tetraoxosulfate 6, H2SO4. So the basicity is 2. Is 2, which is the number of replaceable hydrogen ion. Basicity of an acid is the number of replaceable hydrogen ion in that acid. Let me refill my marker. For tetraoxosulfate 6, the number of replaceable hydrogen ion is 2. Not 3, not 4, not 5, not 6, not 7. Okay? So the options provided, none of them is correct. Ethanoic acid, look at this one, CH3COOH. The basicity of ethanoic acid is 1. That is the number of replaceable hydrogen ion. When this acid is ionizing, how many hydrogen will it give off? When this acid is dissociating in solution, how many acid will it give off? Will it give out? The number of hydrogen ion. How many hydrogen will it give up? That is what determines. The number of hydrogen is going to give out is what determines its basicity. So the option provided here, there is none of them that is correct. We are moving on to the next question, number 15. Once again, group 7. A repetition of question. Which of the following in aqueous solution is neutral to litmus? Which of the following in aqueous solution is neutral to litmus? I think we've answered this question previously. I don't know. Question number what? Let's see, question 5. So you came over and then repeated it again in question 15. Una try. Oh? Una try. So we are moving on. The correct answer of that guy, we said it's sodium chloride. We've answered that earlier. That guy is neutral. All right, Mary Cynthia, you said it's 2. That's great. Mary Cynthia already even dropped the basicity of tetrasulfate 6. It is 2. So none of the options provided is correct. Now, what is the basicity of trioxonitrate 5? Trioxonitrate 5, HNO3. What is its basicity? Drop your answer in the comment section. The basicity of trioxonitrate 5. You know the chemical formula of trioxonitrate 5, right? HNO3. Then what is the basicity of hydrochloric acid also? What is the basicity of tetraoxophosphate 5? Tetraoxophosphate 5. What is the basicity? I'd like you to drop in the comment section the basicity of those guys. Hydrochloric acid, trioxonitrate 5 acid, tetraoxophosphate 5 acid. Drop their basicities. We are moving on to the next question, number 16. We shall be jumping question 15 because, like I said, we've already answered that question. Question 16 reads, when sodium hydroxide is added drop by drop to some hydrochloric acid in a beaker. When sodium hydroxide is added drop by drop to some hydrochloric acid in a beaker, which of the following occurs? Which of the following occurs? A. The pH of the solution decreases. A. The pH of the solution decreases. B. The concentration of hydrogen ions increases. B. The concentration of hydrogen ions increases. C. The concentration of hydroxide ions increases. C. The concentration of hydroxide ions increases. D. The solution turns pink. D. The solution turns pink. E. Sodium chloride crystals forms. E. Sodium chloride crystals forms. And I feel that the correct answer there is option E. Sodium chloride crystals will form. Okay? The reason is this. Look at that option A. Take note, we are looking at what will happen if sodium hydroxide is added drop by drop to hydrochloric acid in a beaker. Now, first of all, you want to understand that that reaction is neutralization reaction. And when neutralization reaction is taking place, what forms if an acid and a base react? Because here sodium hydroxide is a base, right? And then hydrochloric acid is an acid. Am I communicating? When sodium hydroxide is being added drop by drop, neutralization reaction will take place. I know when acid and base react, salt and water form. When acid and base react, salt and water form. The question now is, which salt will form here? The salt that is going to form is sodium chloride. Because in the reaction equation, sodium from the sodium hydroxide will react with chlorine from the hydrochloric acid. Let's see question 16. This is what we are looking at. Okay, this is going to split here. This is going to split here. So sodium will combine with chlorine, giving us sodium chloride, and then water is formed. Now, this sodium chloride, since it is obtained as a salt from a strong base and a strong acid, this guy will be neutral. This solution you are seeing will be neutral. I think we encountered one similar kind of question. Okay, even question 15 that I jumped because we answered it already, I think, in question 4. Sodium chloride, its solution is neutral. Its solution is what? Neutral. So pH, that is the acidity. The hydrogen ion concentration will not increase. It will not decrease. Are you getting me right? Which is why option A said, what do we have in option A there? The pH of the solution decreases. That pH of solution decreases means that you are saying that the resulting solution, the product that is going to be formed, will now be much more acidic. That's the meaning of that. Because if pH is decreasing, you are tending towards acidic medium. Our pH scale is from 1 to 14, which was why when I taught you guys the concept of pH and pOH, I explained that pH plus pOH is equal to 14. pH measures the level of acidity. And in that pH scale from 1 to 14, between 1 to 7 is acidic. 7 to 14 is basic. So when you say that the pH is reducing, in this case, when this reaction is taking place, according to option A, if you say that pH will decrease, it means that you are telling us that the resulting solution will be tending towards acidic level or medium, which is not true. Like I said, sodium chloride is formed from strong base and strong acid. So this salt you're seeing, this normal salt, in solution, in aqueous solution as you're saying it, will be neutral. And if it is neutral, it means that pH will not decrease. It means that pH will not increase. It won't decrease, it won't increase. If it is increasing, it's moving towards alkaline or basic medium. All right, so that's why option A is not the answer. Option B say concentration of hydrogen ions increases. Yeah, still saying that it's tending towards acidic medium. Of course, that is not correct. Then option C said the concentration of hydroxide ion increases. You are saying that the resulting solution will be moving towards the basic medium. That is from 7 to 14. No. Okay, the basic level will not increase. I repeat once again, sodium chloride as a normal salt there is neutral salt in solution. So what really happens here when this reaction takes place is simple, that sodium chloride crystal will form. That is just what is going to happen. Therefore, the correct answer is option E. The sodium chloride crystal will form. Option E is the correct answer. We are moving on. So that's question number 16. So we will be going to question 17. If you have any question, you can ask. I'll be wiping this part of the board, for we are done with this side. All right, so let's see the answers that your friends provided. Mary Cynthia, you wrote 2. 2, okay. I guess that one was the basicity of tetrasulfate 6. Then Chinwe, I saw 3 there. I don't know what that 3 represents. I could have preferred if you guys are dropping that answer, or maybe you drop it according to the way I gave the question. I think I said basicity of hydrochloric acid, basicity of triosonitrate 5 acid, and basicity of tetraoxophosphate 5 acid. But let me assume that the 3 you quoted is that of tetrasulfate 6 acid. Tetraoxophosphate 5 acid, which is H3PO4. The basicity of that guy is 3. There are 3 replaceable hydrogen ions there. Then for hydrochloric acid, it is 1. Yes, Mary Cynthia, good. Amarachi Anita, so HNO3 is 1. That's correct. Good. So you guys have really supplied some wonderful answers to that. So basicity of hydrochloric acid is 1. We have only 1 replaceable hydrogen ion in HCl. Basicity of trioxonitrate 5 acid is 1 because we have only one replaceable hydrogen ion there. Basicity of tetraoxophosphate 5 acid is 3. We have 3 replaceable hydrogen ions there. Somebody might look at this. Let me still come back to this guy before I wipe it. Ethanoic acid. And someone might like, the basicity of this guy is supposed to be 4 because we have 4 hydrogens there. No, it doesn't work that way. Number 1, organic acids are weak acid when they are ionizing. In solution, when organic acids are ionizing, giving out their hydrogen ion, they do not give out this particular hydrogen ion that is attached to this other carbon. We refer to this hydrogen ion as the alkyl hydrogen ion. Okay, we can call them the alpha hydrogen. Because after this carbon, the next carbon that follows it is called alpha carbon. Don't worry, when it is time for us to deal with organic chemistry, you will learn some of those concepts. Organic acids, the only hydrogen that ionize is that hydrogen in the part of COO. Yeah, they now have the H. Here we have only one hydrogen. So don't confuse that with those of mineral acids. All right, we are moving on. We're going to look at question number 17. Question 17. I'll be wiping this part of the board. We have 20 questions here supplied by group 17 of the GMAT 41 JAMB physical class. All right, so group 17. They are the ones that supplied. Is it group 17 or group 7 rather? Group 7, they are the ones that supplied this question. They supplied us with 20 questions, right? And these are real-time exam questions. We're moving on to the 17th question there. Let us see what we've got. Which of the following substances is not a salt? Which of the following substances is not a salt? Which of the following substances is not a salt? Option A, sodium hydrogen trioxosulfate 6. Sodium hydrogen trioxosulfate 6. That thing is not supposed to be sulfate 6. Trioxosulfate is sulfate 5. Trioxosulfate is sulfate 5. We can actually calculate sodium hydrogen trioxo. You can check the oxidation number of sulfur there. Hydrogen oxidation or valency of hydrogen is +1. Valency of sodium is +1. Valency of oxygen is 2 minus. So solving this, 1 atom of sodium here times the valency is 1 times 1, plus 1 atom of hydrogen here times the valency is also 1 times 1. Now 1 atom of sulfur times the unknown valency is 1 times X. Then plus 3 atoms of oxygen times the valency, which is -2. You're going to get -2 times 3. And then all these things will be equal to 0. I'm trying to calculate the oxidation number of sulfur. So I will find out in that option A, that is sodium hydrogen trioxosulfate. Sulfate what? No, group 6. I mean group 7 you wrote sulfate 6. And I'm saying I don't agree with that. The trioxosulfate is not even 6. It's tetraoxosulfate that is 6. Sulfate 6. That is the one that the oxidation number of sulfur is 6. All right, this is going to give us 1. This will give us 1. This will give us X. 1 plus 1 is 2. 1 plus 1 is 2. Then this is going to be X plus this is -6 equal to 0. So if you solve this, X is going to be 4. So this SO3 2 minus, please take note. It is sulfate 4. Sulfate 4. Take note of that, please. If it is SO4, it will be sulfate 6. All right. I'm not teaching you oxidation number calculation on the board, so I have to wipe it. Just trying to correct the oxidation number of sulfur given there. So option A, remember the question we are answering. Which of the following substances is not a salt? Option A, sodium hydrogen trioxosulfate 4. Option B, lead-2-trioxonitrate 5. Option C, basic zinc chloride. Basic zinc chloride. Option D, aluminium oxide. Option D, aluminium oxide. Then option E, washing soda. I am going to write these options on the board. However, I will not use their names given there, their UPAC names straight. I'm going to write their molecular formulas, please. All right, so question number 17. Question 17. So option A here, remember the question, which of the following is not a salt? That first option is sodium hydrogen trioxosulfate 4. Then the second option B is lead 2 triosonitrate 5, written like this, PbNO3, then 2 outside. And then option C, we have basic zinc chloride. Basic zinc chloride is written like this. All right, that is zinc hydroxide chloride. Then option D, we have aluminium oxide. This is aluminium oxide. And then option E, we have washing soda. Washing soda is this. This is washing soda. Washing soda. So the question is, which of the following is not a salt? Which of the following is not a salt? The correct answer is this option D. Option D is aluminium oxide. That guy is not a salt. Aluminium oxide is an amphoteric oxide. Amphoteric oxide. It has both basic and an acidic behavior. Are you getting me? It can behave as a base, it can behave as an acid. Amphoteric oxide. The rest are salts. The rest are salts. This guy is acidic salt. Acidic salt because you can see hydrogen there. This guy is normal salt. Lead 2 triosonitrate 5 is normal salt. There is no hydrogen there. This guy is basic salt. Basic salt. You can see OH there showing that it has some basic character there. This guy is, I think, let's see, which salt is this? This is not double salt because it doesn't contain 2 cations. Okay, let's say that this is hydrated salt, hydrated normal salt, hydrated normal salt. So this is salt, this is salt, this is salt, this is salt. But this guy is not a salt. All right, so copy that. All right, guys, I hope we are learning right. We shall be moving on to question number 18. Question 18. Now, I hope this is not cutting off the board edge. I hope it's showing. Question number 18. Let us see what we've got there. An acid can react with A, we have silver chloride. B, we have sodium trioxocarbonate 4. C, we have lead tetraoxosulfate 6. D, we have sodium tetraoxosulfate 6. So which of these guys will an acid react with? An acid can react with sodium trioxocarbonate 4. An acid can react with sodium trioxocarbonate 4. If an acid reacts with sodium trioxocarbonate 4, there is one gas that is always giving off. If an acid reacts with sodium trioxocarbonate 4, you know, the trioxocarbonate group, there is one of these gas that will usually be given off, right? That gas turns lime water milky. Tell me what that gas is in the comment section. You might also decide to write the chemical equation when an acid reacts with sodium trioxocarbonate 4. Salt will be formed, water will be formed, then one gas will be given off. I'd like to know that gas. Drop that in the comment. Oh my gosh. Mary Cynthia, I love that, right? Yeah, I love that from you. You have not even waited for me to be done with the question and then you drop the answer. Kudos. That is great, okay? The correct answer is carbon dioxide. The correct answer is carbon dioxide as you posted in the comment box. That is CO2. So take note, friends, whenever acid reacts with triazocarbonate groups, they produce carbon dioxide gas. All right, we are moving on to question number 19. Mary Cynthia, I've got a gift for you, okay? I've got a gift for you, but you will drop in our WhatsApp group, or perhaps do this, drop your phone number that you may wish to be recharged for you, okay? So I'm going to send airtime. I'm going to send you airtime. Okay, that'll be coming from GMAETS 41. Drop your phone number, which you might wish to be recharged. So I'll send you an airtime, 500 airtime unit, okay? 500 unit airtime at the end of this class. I'm waiting to see your number, okay? So that I can copy it, because once this class is off, most of all this comment I know will not be available again. So drop it now. Let me copy out the number. We are moving on to question 19. Question 19. And of course, you know that is $0.5 from GMAETS 41. Right? $0.5 for you on that. So drop your phone number, please. Let's move on to question number 19. Question number 19 reads, in titration involving sodium hydroxide and dilute hydrochloric acid. In titration involving sodium hydroxide and dilute hydrochloric acid, where would you place the base? Where would you place the base? So if you have been opportune to run a live titration experiment, this question is 1 + 1. Where do you place the base whenever you are carrying out neutralization reaction? You know, in titration process, where you carry out reaction between acid and base, generally. So the question now is, where would you place the base? A, in the beaker. B, in the conical flask. C, in a burette. D, in the standard flask. E, in the measuring cylinder. In titration involving sodium hydroxide and dilute hydrochloric acid, where would you place the base? The base is placed in a conical flask. So the correct option here is option B. That conical flask, you know, the diagram I think is something like this. If I still remember in those days, okay? Then usually you will pipette the base from a beaker. This question is a bit tricky. That beaker they gave there, some persons might mistakenly go and select it, because they say first what you will do, the container you use in collecting the base is flat bottomed beaker or flask rather, okay? So and then from there you can now pipette your base and pour it into the conical flask. In the main titration process, you know, when you start adding acid from the burette into the base, that base will be in the conical flask. You usually hold the conical flask and then you shake. So that is it. Don't mind this, my conical flask. I don't know what it looks like. So the correct answer is conical flask, like we said. That is where you place your base. And of course, that is option B. Option B, which is conical flask. Then finally, we have question 20. That is finally here, question 20. I still have some other important questions I want us to look at, but I'm going to be a bit fast in answering them, okay? Question 20 reads, the pH of 4 solutions, W, X, Y, Z are 4, 6, 8, 10. The pH of 4 solutions. The solutions, question 20, the solutions are X, Y, right? W, X, Y, Z. The pH of these guys are 4, 6, 8, 10, respectively. The pH of 4 solutions W, X, Y, Z are 4, 6, 8, 10, respectively. Therefore, basic, something like this. This is 7, 1 to 7. This is 7, 1 to 7, and then let's say 14. Here is acidic medium, acidic, and this part is basic. This part is basic. So any number between 1 to 7, 7 is neutral. 7 here is neutral. Neutral. That's 7. So from 1 to before 7 is acidic. And then just after 7 to 14 is basic, which means that Y is a basic solution. If you are adding water to a basic solution, it does not change the base to acid. It doesn't. Rather, it dilutes the base. It dilutes the base the more, making it highest that can happen there is maybe making it very, very diluted. All right, it won't change to whatever. So that option B says the pH of Y is made more acidic by addition of distilled water. Now, option C, Z is most acidic solution. Z is most acidic solution is wrong. Z is in this range 10, so it is even the most basic, not most acidic. D, W is the most acidic solution. Of these 4 guys, W is the most acidic solution. That's the correct thing. Because if you look at this, say 1, 2, 3, 4, 5, 6. You notice that you cross 4 before 6. And the more you are going to the left, the more acidic that solution will be. So these 4 guys, W is of pH 4. Therefore, it is more acidic than the rest 3 solutions. That is the correct answer, friends. That's the correct answer, option D. W is most acidic solution in this comparison. Option E said X is neutral. X is neutral. X is 6. 6 is not neutral. 6 is still acidic medium. So the correct answer here in that question 20 is option D. That's the correct answer. So this is how we are done with the 20 questions provided by group 7 of the GMAS 41's JAMB class. If you just connected to this class, perhaps you are not a member of GMAS 41's JAMB lesson, remember to subscribe to this channel. You can always follow us online. Are you following right? You can follow us online as we have our classes, and you would be glad that you did. More so, can become a channel member. How can you join the GMAS 41's online learning community? To do so, just below this video, below this particular lesson going on, you have the Join tab. You can click on the Join tab, then select the GMAS 41's Platinum or Diamond level package. Support this channel, and then you become a channel member. Don't forget to turn on the notification bell if you subscribe. Subscription is free. Yeah. So feel free to subscribe. Remember to turn on the notification bell. What is the advantage of that? So that once I upload any content or once I am live like this, you will receive a notification. All right, so we are done with this particular review of the 20 questions provided by group 17. There are just some questions I want us to deal with further before we can close up the class for today. All right, so I'm going to wipe the board now, and then I will dictate these questions from my end. None of you have these questions, so you pay attention as I dictate them, and then I will provide answers to these questions. Group 17, you did not do realistic work. Take note. You did not do realistic work. You tried though by providing questions. But you see, there are so many questions on acid, base, and salt that I could have provided. I didn't see any question on pH calculation, pOH calculation. I didn't see any question on preparation of salt, you know, stuff like that. I didn't see any question on efflorescence, you know, deliquescence, hygroscopy. I'm wondering if you didn't see any such question. But of course, it's not possible. Right? So make sure you put in more effort next time you have this privilege. It's a privilege for your group to provide questions for us to answer. So you want to take that seriously, please. I'm not fully satisfied. And I think I kept complaining about that, about group 7 in this question you provided. So, meanwhile, or at least you've done what you could do, just that you want to work more next time. I have this question, please. I have this question. I'm going to dictate it. An anhydride is A compound which has no water of crystallization. B, an oxide whose solution in water has a pH greater than 7. C, an oxide whose solution in water has a pH less than 7. That is the correct answer. D, an oxide that has hydrogen atoms. That is wrong. It doesn't make sense. So the correct answer to this question is that an anhydride is an oxide that has pH less than what? 7. Remember that anhydride, okay, acid anhydride, we say those guys, they will dissolve in water in solution and produce what? Acid solution. And so if an anhydride will dissolve in water and produce acid solution, for acid solution, the pH is less than 7. Therefore, we conclude that anhydride, they are substances whose solution would have pH less than 7. So you take note of that. From here, the correct option, in terms of the options provided and I read out to you, the correct option is meant to be C. An oxide whose solution in water has a pH less than 7. Next question I want us to look at is this. An acid is said to be weak if A, its ions are so completely dissociated. Its ions are so completely what? Dissociated. B, the acid is not corrosive. The acid is not corrosive. C, the acid has low specific gravity. The acid has low specific gravity. D, its ions are incompletely dissociated. Its ions are incompletely dissociated. And of course, that's the correct answer. Weak acids, whenever they undergo dissociation, their ions do not dissociate completely. That is to say, the ions in this case is the hydrogen ion to be specific. The hydrogen ion to be specific. If an acid is said to be weak, during ionization, the ions will ionize partially. They will not dissociate completely. And that is what option D here talks about, that its ions are incompletely dissociated. So the hydrogen ions you have there, all of them will not dissociate. A good example is you having CH3, COOH. Remember, during dissociation, this guy will lose, as in it will give out this replaceable hydrogen ion, only one of it. So you get CH3, COO negative, and then H positive. You notice that not all the hydrogen ions dissociated. Not all of them. So some of the ions are still there, some of the hydrogen ions. And that is why we say that this ethanoic acid is a weak acid. When it dissociates, the dissociation is not complete. It's partial. So the correct option here is option D. Therefore, you want to take note of this. A weak acid is one in which the ions do not dissociate completely. Or you can say one in which all the hydrogen ions are not given up. All the hydrogen ions, okay, it's not being replaced in the process. Just some of them will be replaced. Now, the next question I have here is this. Neutralization involves a reaction between hydroxonium ion and neutralization reaction involves a reaction between hydroxonium ion and what? Now look at the options given. First of all, get to know your hydroxonium ion. This is hydroxonium ion. You can call it hydroxonium ion or you can call it hydronium ion. Hydroxonium, or you can call it hydronium ion. So neutralization reaction is reaction between hydroxonium ion and what? Now take note that this guy, there was something I said earlier, this is a form in which hydrogen ion exists in solution according to Brnsted-Lowry's definition of an acid. According to Brnsted-Lowry's definition of an acid. This is a form in which hydrogen ion will exist. Because according to Brnsted-Lowry's definition of an acid is a substance. An acid is a substance that will accept a proton. That we give out, rather, think the definition I gave there, Brnsted-Lowry, for Arrhenius definition, it's in terms of the one that we give out, hydrogen ion. Okay, then if you talk about Brnsted-Lowry, it's about releasing and accepting a proton. So an acid is one that gives out a proton, while a base is one that accepts a proton. Take for example, if I give you something like this, HCl, and then plus water. During this reaction, this hydrogen will give out, this hydrochloric acid will give out hydrogen to water. So this is the acid. It's the acid because it donates a proton. It gives a proton to this water. Now, this hydrogen that is transferred to water, instead of the hydrogen to exist as this alone, it won't exist in this form. In this form, it is Arrhenius definition. Whenever you see hydrogen exist in this form, it is Brnsted-Lowry's definition. And what makes it to exist in that form? Now watch. When this hydrochloric acid gives this water the proton, the hydrogen ion, this water will now turn to something like this. So you notice that inside this ion, you have hydrogen ion that was transferred from here. Inside this ion, you have hydrogen ion that was given off by this acid. So the acid donated the proton to this water. This water is serving as a base. It's serving as what? A base. So this is now going to give us Cl negative. It's going to give us Cl negative. So this is just the concept, all right? And what you see here on the board is according to Brnsted-Lowry's definition of acid and base. Like in this case, this is the acid, which is the substance that gave out a proton. This water is the base, which is the substance that accepted the proton. If you come here, the reaction can be reversed. Now look at these two species, hydroxonium ion and chloride ion. Which one will give out hydrogen in this case? You'll agree with me that hydroxonium ion will donate a proton, will give hydrogen ion to this chloride ion. Therefore, since this H3O positive is giving out a proton or hydrogen ion, this guy will be the acid here, and this will be the what? Base. And this is what brought in the concept of conjugate acid and base pair. But remember, this definition is according to who? Brnsted-Lowry, not according to Arrhenius. According to Arrhenius, a proton exists as hydrogen ion. But according to Brnsted-Lowry, a proton exists as hydroxonium ion. Now let us get back to this question once again. Neutralization involves a reaction between hydroxonium ion and... So I just took my time to explain this concept of the formation of hydroxonium ion. Options that were provided are A, chloride ion, B, hydroxide ion, C, trioxonitrate 5 ion, D, trioxocarbonate 4 ion. The correct answer is hydroxide ion, OH negative. Let me list the options given there. I will still wipe it because I'm not writing any options there. Option A, Cl negative. Option B, we have OH negative. Option C, we have trioxonitrate ion. And then D, we have CO3 2 minus. So the question is, neutralization reaction involves a reaction between hydroxonium ion and which one of these? And the correct answer, like I said, is B. When hydroxonium ion reacts with hydroxide ion, that reaction is called neutralization reaction. And of course, it's true. Because remember, neutralization reaction is reaction between acid and base, or simply put, reaction between hydrogen ion and hydroxide ion to form water. So in this case, this thing is serving as hydrogen ion. Remember I told you that hydrogen ion is hidden inside this hydroxonium ion. So look at how the reaction goes. H3O positive hydroxonium ion plus OH negative. Now our main focus as product is formation of water, because that's what defines neutralization basically. Now hydrogen will be given off. Hydrogen will be given off from here. Right, that's hydrogen ion. Together with this hydroxide ion, we form water. So this is what we are going to get, H2O. You now talk about balancing it. How many hydrogens do we have in the reactant? 3 hydrogens plus 1 hydrogen, making it 4 hydrogens. So attach 2 here to balance hydrogen. How many oxygens do we have there? We have 2 oxygens, and it's the same as the product. So the equation is balanced, and this is neutralization reaction. Neutralization reaction. So in defining neutralization reaction, we can still say it is a reaction between hydroxonium ion and hydroxide ion. In class, you remember I defined it. The other alternative definition I gave, neutralization, was the reaction between hydrogen ion and hydroxide ion. Hydrogen ion from the acid, hydroxide ion from the base. Take note that the hydrogen ion is still the same as hydroxonium ion. Besides, this guy is acting as a base. As an acid. I just explained that here. All right, so we are done with that particular question. Let's see the next that I have for you. Let's see the next that I have for you. Okay, let's look at this question. Let's look at this question. This is the reaction here. Actually, the question has that reaction there on the board. So permit me to wipe this guy. Permit me to wipe this. I've explained it. And then, okay, I can leave this one. Nothing is there. But the question I'm about to dictate has something to do with this. That is why I'm leaving it. All right. Oh, I need to adjust it. This is not exactly that. So this is what we have. We're given CH3, COOH, and now aqueous form plus OH negative aqueous, and then we have this. Let me write the products given here: CH3, COO negative aqueous plus water, H2O liquid. So this was given to us. This was given to us. And the question is, in the reaction above, CH3, COO is there. In the reaction above, CH3, COO is the what? We don't know. Now listen to the options given. Perhaps let me list the options on the board. Option A, we have conjugate base. Conjugate base. Then option B, we have acid. We have acid. Option C, we have base. And then option D, we have conjugate acid. Conjugate acid. Conjugate acid. So the question here is, in this reaction given to you here, look at it. This carboxylate ion, because the name of that ion is carboxylate ion. What is it in this reaction equation? Thank God I've actually analyzed something here a bit, following Brnsted and Lowry's definition of acid and base. Okay, an acid is a substance that donates, that gives out a proton, while a base accepts a proton. So what is the function of this guy in this reaction? What is it? Coming to this, how to identify it is, get your acid, get your base. In this case, during this reaction, you notice that this CH3COOH, in the product, there is no H in it again. What does it mean? It means that this guy transferred hydrogen to this OH. Now, if you look at this OH, in the final product, you notice that it now has two hydrogens. So what is the whole idea here? This guy is your acid here. Is your acid because it donated, it gave out hydrogen ion, it gave out a proton to this guy. This guy accepted the proton, therefore this is the base. This is the base. Coming to the product, let me ask you, if this reaction is to be reversed, if it is to be taken back, which of these two species will donate a proton, will give out hydrogen? Is it this one or this one? Now take note that this hydrogen cannot be given off. Therefore, it is this water that will now give hydrogen to this carboxylate ion. So in the reverse reaction, if this water is giving hydrogen to this carboxylate ion, it means in the product side, the water becomes the acid and this becomes the what? Base. So what do we have? You see this guy, acid. Acid from reactant, base from product. They form what we call conjugate acid-base pair. Acid from reactant, base in the product. They form what we call what? Conjugate acid-base pair. Acid from the product, base in the acid from the product, base in the reactant. They form what we call conjugate acid-base pair. Am I communicating right? So simply put, this guy you are seeing here is called conjugate base. This CH3COO negative is called what? Conjugate base. This is the conjugate base to this acid. Therefore, the correct answer is what? Is option A. This is the conjugate base. Please take note. You pick acid, you talk about the conjugate base. You pick acid, you talk about the conjugate base. You don't just have base like that. No. The base always is taken to be a conjugate base. Are you following right? So the correct answer is option A. CH3COO negative is conjugate base. Good, Mary Cynthia, that's great. That's wonderful answer from you once again. But I've not seen your phone number, or you don't want to drop it here in the public group. Anyway, it's understandable, but you can send it. You can send it to me personally or however I want it to be, okay? Yeah. Don't post here anymore. I think I understand it. It's public domain. You can't just drop your number there, but you can send it to me directly. Okay, you can send it to me directly. So I will fulfill my promise for what I want to do in giving you 500 units of airtime. Now we have this question next that I'd like us to look at. We have this question next that I'd like us to look at. And the question reads, what is the pH? What is the pH of a 0.001 mole per dm cube solution of sodium hydroxide? Once again, what is the pH of 0.001 mole per dm cube solution of sodium hydroxide? We have the options given, or dictate the options when we are done solving. What is the pH of 0.001 mole per dm cube of sodium hydroxide? This question is tricky. Anytime I teach this in my classes, I always talk about it. Imagine somebody telling you to calculate pH for a base. And in fact, sometimes they will give you an acid and say you should find pOH of the acid. quite funny, right? Because normally when we hear pH, we should be thinking of acid, since it measures acidity. And if we hear pOH, we should be thinking of base, since it measures the amount of, alkalinity. But then an examiner will give you a base and say, calculate the pH of the base. In our physical JAMB class, I explained something that no acid is 100%. For example, the acid with the highest percentage purity is tetrasulfate 6. If you go to a chemical shop and you buy tetrasulfate 6, you would see written in the reagent bottle 98% pure, which means that the acidity of that solution is 98%. Where did the remaining 2% go to? I always ask that question. That remaining 2% definitely has a concept of the alkalinity of that guy. So for every acid, you can find the pOH. For every base, you can find the pH, because there is a little level of acidity or alkalinity in the opposite pairs. Therefore, this question is not wrong, it's very correct. We are given sodium hydroxide, that is the base, and then we are given the concentration of the base. Now, the concentration of the base from the question is 0.001 mole per dm³. Take note now, once the concentration of a base is given to you, dear friends, what they gave to you is hydroxide ion concentration. What they gave to you is what? Hydroxide ion concentration. Why? Because a base, the functional group of a base is OH negative. Hydroxide ion is what determines a base. So you giving me sodium hydroxide and the concentration of sodium hydroxide, what you have succeeded to give to me is the hydroxide ion concentration of that sodium hydroxide. So from the question, the hydroxide ion concentration is 0.001 mole per dm³. Mole per dm³. That is also the same as mole per liter, because dm³ and liter are the same. And we can simply write it as 0.001 molar. Molar is the same as this unit. Now we are asked to find pH. Normally the definition of pH, look at it, pH is equal to negative logarithm of hydrogen ion concentration to base 10. This is the main formula of pH from the definition of pH. Which means if I want to calculate pH of anything, I must know the hydrogen ion concentration. But unfortunately, what was given to me here is a base. So the concentration quoted in that question is not hydrogen ion concentration. That concentration is hydroxide ion concentration, which means I can't use this formula to calculate the pH of this question directly. You can't use this to calculate the pH of sodium hydroxide. It's not done. So how do we approach it? If you are given a base, you can only calculate pOH of that base. If you are given an acid, you can calculate the pH of that acid directly. But if you are given a base and say, find pH of the base, you can't get it directly. I must tell you this. Especially in a case where you are given a concentration of the base. Why can you not calculate it directly? The concentration quoted is hydroxide ion concentration, not that of hydrogen ion. So this is what we are going to do. Given this hydroxide ion, we are going to calculate pOH. pOH has this formula to be equal to negative logarithm of hydroxide ion concentration to base 10. Just like we have pH in the case of acid. In the case of base, pOH has this formula. So I'm going to get my pOH, and then from pOH, I'll now get the pH of this sodium hydroxide. So this is going to be negative logarithm. Hydrogen ion concentration is 0.001 and then base 10. Now I can rewrite this as pOH equal to, I believe that in your JAMB, if examiner is giving you questions on this, maybe calculate all this pH, pOH. Concentrations they are going to give to you will be that in which you can solve that question without calculator. Yeah, because the system's calculator, I don't think it has raised to power. It does not have logarithm, so you cannot press this in directly with the system's calculator. Therefore, values that JAMB would give, or any other professional exam body that want to test you on questions on this pH and pOH calculation, if they don't want you to use calculator, definitely it is your right as a student for the examiners to give you questions that you solve without calculator. And this is one of them. The concentration given, I can rewrite it as negative logarithm. This 0.001 is the same as 10 to the power of minus 3, then base 10. Are you following, right? We can now apply power law of logarithm. Power law of logarithm. What does that law say? If I have log a raised to power x, the law says we should use the power of this number to multiply the logarithm, which means this is equal to x times log a. Now, if you look at this logarithm term here, the number itself is 10. This is read as minus log 10 to the power of minus 3, then base 10. The number itself is 10 to the power of minus 3. The power of this number is minus 3. So take that minus 3 to the back of that logarithm. POH will now be equal to minus 3, open brackets, minus log 10 to base 10. You see, this minus 3 is multiplying this log from behind, just like I showed you here. Now, minus 3 times minus 3 will give you plus 3. Minus 3 times this minus 1. There is invisible 1 here. Minus 3 times this minus will give you plus 3. Take note of that. Then logarithm of 10 to base 10. Log of 10 to base 10 is equal to 1. The logarithm of any number to the same base, mathematics tells you that it is equal to 1. Which means that this is going to be written as minus 3, open bracket, times minus 1. Where did this one come from? Log 10 to base 10. The same thing, log 5 to base 5 is 1. Log 7 to base 7 is 1. Take note. Minus 3 times minus 1 is going to give you 3. I had to take my time to show this calculation step by step. At least I know some persons usually have issue. They don't like maths, and that is why my students, my JAMB student, the GMAETS 41's JAMB students, I made maths compulsory for them. I made maths what? Compulsory for all of them, whether you are taking maths in JAMB or not. You need the knowledge of maths to be able to survive some of your calculations in chemistry and in physics if you are exposed to them in your exam. So we have gotten pOH of this guy, it is 3. Therefore, we can now obtain pH of that sodium hydroxide. Remembering that pH plus pOH is equal to 14. That's the relationship between these two guys. Therefore, pH will now be equal to 14 minus pOH. You know, the pOH will cross. And now our pOH is 3. So it's going to be 14 minus 3. pH of that sodium hydroxide is 11. So that is the correct answer. And there we have the options A, 14, B, 13, C, 12, D, 11. So the correct answer is D, which is 11. All right. This is great. We have this next question. Let's see how far we've spent before I end the class. Okay. So I'll soon round off, at least the questions I want us to look at. Soon round off. I'm going to wipe this part of the board. You can copy, if you're here to copy it. Like I always advise, you can screenshot. If you screenshot, it will be faster, so that I'll wipe the board. And then we round off with the remaining calculations. All right, so we are moving on. Okay, so let me wipe this part. All right, so the next question I'd like us to see is this, and it reads, the mathematical expression of pH. The mathematical expression of pH is, permit me to list the options. The mathematical expression for pH formula, let me just assume it, let me put it this way, pH formula. The mathematical expression of pH is option A. We're given log of hydroxide ion concentration to base 10. Is this the formula of pH? We're going to find out. Option B, we have log of 1 divided by hydroxonium ion concentration base 10. And then option C, we have log of hydroxonium ion concentration, log of hydroxonium ion concentration, and then option D, we have log of 1 divided by hydroxide ion concentration to base 10. So these are the options provided. Which of them is the mathematical expression of pH? Which of them is the mathematical expression of pH? So the pH formula, okay, I've wiped it from the board here, but take notes. pH, because the answer to this guy, from what I'm saying, is this guy, option B. But let's find out, by definition, pH is equal to, that is mathematical definition, negative log of hydrogen ion concentration base 10. Now, in this life class, I had stated that your hydrogen ion concentration can still be written, that is, hydrogen ion is still the same as hydroxonium ion. I said something based on Brnsted-Lowry's definition of acid and base. This is according to Arrhenius. So you talk about hydrogen ion. According to Brnsted-Lowry's definition, hydrogen ion, you refer to it as hydroxonium ion, which means whether I write the hydrogen ion concentration as this or I write it as this, they are both the same. They are both the same. So permit me to rewrite that pH to be equal to negative logarithm of hydroxonium ion concentration to base 10. So this is the formula of pH. This is the mathematical expression of pH. One could think, okay, maybe the answer could be this guy, but that is not the answer. Why? Observe that at the back of this logarithm, there is no minus in the option, but here there is a minus. There is what? A minus. Now remember telling you in class that there is a law of logarithm. If you change the sign at the back of logarithm, if you change the sign at the back of logarithm, the number in front of that logarithm will be inversed, will turn upside down. This thing you are saying is minus logarithm of hydroxonium ion minus logarithm of hydroxonium ion concentration base 10. This concentration you are seeing is divided by 1. So I can rewrite the pH again to be, I don't want to maintain this minus again, I'm making it positive. So I'll have logarithm. That will make me to turn this thing upside down, inverse. This thing is over 1 you are seeing. So the 1 will go up, the hydroxonium ion concentration will come down. So that becomes 1 divided by hydroxonium ion concentration, and then I have your base 10 here. You see, there is no minus behind the logarithm again, thereby making this thing 1 over. And that is why the correct mathematical expression for pH is option B, given there. We are moving. I think we are close to rounding off. There are just a few questions I'd like us to consider as we round off, okay? Just a few questions. So. I have this question here. It reads, just pay attention. We've treated this in class under preparation of salts. Okay, so you pay attention as I dictate it. So you answer. And there is a question. Silver chloride is prepared in the laboratory by, silver chloride is prepared in the laboratory by A, double decomposition, B, action of an acid upon a metal, C, neutralization using an insoluble base, D, neutralization using soluble base. I take the question again. Silver chloride, that is AgCl. Silver chloride, AgCl. How do you prepare it in the laboratory? Option A, double decomposition. I like that guy. If you are with GMAETS 41 and you've attended our lesson on acid, base, and salt, You will also like this option A, double decomposition. Option B, action of an acid upon a metal. Now. Option C, neutralization using an insoluble base. Now. Option D, neutralization using a soluble base. No. You see, option B, C, and D are used to prepare soluble salts. Silver chloride is insoluble. Silver chloride is insoluble. And because silver chloride is insoluble, when you're talking about method of preparing insoluble salt, I think we have two major methods. By double decomposition and by direct combination of constituent element. That is the element that make up the salt. Combine them straight. For example, if you want to prepare something like iron 3 chloride, combining iron and then chlorine gas to get iron 3 chloride, that guy is direct combination of constituent element. But now in preparing silver chloride, what we use is double decomposition. Yeah, double decomposition. And what is double decomposition all about? You react two soluble salts. You react two soluble salts. Then it will precipitate one insoluble salt. Whereas the other salt will now be what? Soluble. So the correct answer here is double decomposition. I'm going to write the reaction equation using something like sodium trioxonitrate 5 and silver maybe sodium chloride and silver trioxonitrate 5. I'll use it to show you the reaction. Finish up what is on the board. Finish up what is on the board so that I can wipe it and then write a chemical reaction equation for double decomposition. Remember, I told you I am going to use silver trioxonitrate 5. Silver trioxonitrate 5 is a soluble salt. It's a soluble salt. So I will react it with sodium chloride. Sodium chloride is also soluble. Wiping here. Sodium chloride is also what? Soluble. So these two soluble salts, when they react, it will precipitate an insoluble salt. And one of them is silver chloride, like I said. So silver nitrate aqueous plus sodium chloride aqueous. Okay. These two guys are soluble salts. Now, when they react, what is going to happen? Let me indicate this guy is soluble. This one is soluble. Now, in double decomposition, this will split here, this will split here. Then they will react. Okay? A displacement reaction will take place. It's a double decomposition because two of these guys, they are splitting and then they are giving each other something. Silver will react with chlorine to give you silver chloride, which is the insoluble salt. Sodium will now react with this trioxonitrate to give you sodium trioxonitrate 5. So this is our insoluble salt. Insoluble salt. Okay? Now, this is the way in which silver chloride is prepared. That reaction above is double decomposition reaction. The reaction here is double decomposition. All right, so that's it. Those taking JAMB, make sure you follow up with GMAS 41. If you keep the pace with this channel, say it is certain that you're going to blast your subjects. You're going to blast your subjects 90 and above. At the end of everything, you'll be seeing yourself in the range of 300 and above. Yes, I always say the student that blast 300 and above, they don't have 7 hertz. So you students too, if you know you are taking JAMB, be aware of this. I hope that next set, those who will take JAMB would start early to be preparing. You don't wait until it is late. Okay, but within the little time left to JAMB, I think it's going to be around 23rd of April or so, 23rd, 24th, or 25th. Make sure you study regularly. At least give not less than 4 hours to your study every day. You can increase more than that hour to help you get prepared, cover your course, outline your subject, and then, of course, if you cover the scheme of work, you move on into exam hall, you can be able to deal with it very well. Okay, now we have this next question. We're just going to take this question and maybe one more, then we close. Listen to the question as I read it. Double salts usually contains option A, 2 anions only. That is wrong. Option B, 2 anions and 1 cation only. That is wrong. Option C, 2 cations only. That is wrong. Option D, 2 cations and 1 anion only. Yes, that is what makes up double salt. Double salt contains 2 cations and 1 anion. And generally, double salts have this general formula. Your examiner will want you to know about it. There are 2 cations there. One of the cation is a univalent cation. The other one is a trivalent cation. And then you now have 1 anion. Then most often you have water of crystallization attached. So we write it this way: M plus, M3 plus. Then we have SO4 2 minus in most cases, right? SO4 2. This is the anion. This is what? The anion. This thing you are seeing is your double salt. It's your double salt. But like I said, usually in most of them you have your water of crystallization attached. So these are the 2 cations. Univalent cation. This univalent cation can either be sodium or potassium or ammonium ion. Are you following, right? Then we have this, which is trivalent cation. This is trivalent cation. Trivalent cation. Usually aluminium, or it can also have chromium 3. Are you following, right? And then this is the anion. The anion most time is tetraoxosulfate. The anion is this guy. So you see, you have 1 anion and 2 cations only. All right, so have I got something else? I have this question. I say the type of salt that ionizes. The type of salt that ionizes to produce 3 different ions in solution. The type of salt that ionizes to produce 3 different ions in solution is, and that's still the answer here. It's another question, but you see the way the question was presented. Okay, the one that I analyzed here said double salt usually contains, we said it's 2 cations and 1 anion only. Now this next question said the type of salt that ionizes to produce 3 different ions in solution is what? The answer is still double salt. Options say we have A, acidic salt, B, complex salt, C, double salt, and D, basic salt. The correct answer is double salt, right? We have 3 ions there. 1 is univalent ion, 2 we have trivalent ion, and then 3 we have anion. Okay, so next, let's look at this question. The question here reads, on exposure to the atmosphere, a hydrated salt loses its water of crystallization to become anhydrous. On exposure to the atmosphere, a hydrated salt loses its water of crystallization to become anhydrous. Anhydrous is spelled this way. Anhydrous, meaning dried, right? Containing no water of crystallization. On exposure to the atmosphere, a hydrated salt loses its water of crystallization to become anhydrous. This phenomenon is referred to as what? This phenomenon is referred to as A, efflorescence, B, deliquescence, C, hygroscopy, D, hydrolysis. What is the answer? Let me see what the answer is. Mary Cynthia, efflorescence, that's good. Amarachi Godwin, Henry Madwabuchi, you answered double decomposition here. That's good. That's good. All right. Now, this next question we just read. Are you following, right? This next question we just read. You expose the hydrated salt to the atmosphere. It lost all its water of crystallization. That process is known as what? That phenomenon is known as what? The correct answer is efflorescence. Option A. Mirachi Godwin selected A. That's correct. Mary Cynthia mentioned efflorescence. Madu Abuchi mentioned efflorescence. That's correct. Are you following? Efflorescence is a phenomenon whereby a salt, when exposed to the atmosphere, loses what? All or some of its water of crystallization. Is that okay? So the correct answer is A, efflorescence. We have deliquescence, hygroscopy. In deliquescence, if you expose a substance to the atmosphere, if that substance is a deliquescent substance, a phenomenon will take place. And what is the phenomenon? The substance will absorb moisture from the atmosphere, and then turn to solution. And then what? Turn to solution. That phenomenon is deliquescence. Then hygroscopy. What is that phenomenon under the study of salt? In hygroscopy, it's similar to deliquescence, but just a little different. You expose the salt to the atmosphere, or you expose the substance to the atmosphere. It will absorb moisture from the atmosphere. But then becomes sticky. Becomes what? Sticky. Which means it won't form solution. It will not turn to solution like the case of deliquescence. Hygroscopy, that phenomenon, once the water of crystallization or moisture is absorbed from the atmosphere, that hygroscopic substance will become sticky. All right, so take note of the difference between deliquescence and hygroscopy. Deliquescence absorbs moisture from the atmosphere and turns to solution. Hygroscopy, that phenomenon, the substance absorbs moisture from the atmosphere but does not turn to solution. Rather, it will become what? Sticky. So that is it. We have this question. An insoluble salt can be prepared by. I already mentioned two major ways of preparing insoluble salt. We discussed that in class also, right? A, the action of dilute acid on an insoluble salt. That is wrong. When dilute acid acts on an insoluble salt, the salt you get is a soluble salt, not insoluble salt, okay? When dilute acid acts on an insoluble base, the salt you will get is a soluble salt. But the question we are dealing with here said, an insoluble salt can be prepared by which method? All right, option B, the reaction of metals with an acid. That is wrong. When metals react with acid, the salt you get is soluble salt, not insoluble. Option C, the reaction of trioxocarbonate 4 with an acid. That method is not used to prepare insoluble salt. That method, reaction of acid and trioxocarbonate, is used to prepare soluble salt. So take note of this, you see, so you get to know the method used for soluble salt. But our focus is the method used for what? Insoluble salt. Now let us see option D, double decomposition. Still double decomposition. But don't forget the second method, direct combination of the constituent elements. Can also be used to prepare insoluble salt. But the correct answer here is double decomposition. Okay? Now we have this question. We're almost rounding off, okay? We're almost rounding off. Which of the following salts will change red litmus paper to blue? Which of the following salts will change red litmus paper to blue? Let me wipe off this part. Where will I wipe? Think here. Which of the following salts will change red litmus paper to blue? Now I want to list out the options provided. Now we're talking about changing red to blue. Red to what? Blue litmus. Which salt will do that? Option A. We have sodium chloride. As I was reading, it was written in its IUPAC name like this, sodium chloride. And B, but you know sodium chloride is NaCl. We have potassium, hydrogen, tetraoxosulfate 6. Potassium, hydrogen, tetraoxosulfate 6. Sulfate 6. And then C, we have sodium trioxocarbonate, sodium trioxocarbonate 4. Carbonate 4. Then option D, we have option C, sodium trioxocarbonate 5. It's carbonate 5 that was mentioned. Wow. What a tricky question. Option D is potassium trioxocarbonate 4. Carbonate 4. Potassium trioxocarbonate 4. So which of these salts will change red litmus paper to blue litmus? First of all, this is what you want to take note of. The substance that changes red litmus to blue litmus is a base. Is what? A base. A base changes red litmus paper to blue, while an acid changes blue litmus paper to what? Red. But our focus here is the salt that will change red litmus paper to what? Blue. So what we are going to be looking at here is the salt that is basic. Any salt whose solution is basic will change red litmus paper to blue, just like base changes red to blue. And what is the correct answer here? I am going to use certain elimination method so that at least I give a little explanation to the options here. Sodium chloride is not the answer. Sodium chloride, the solution is neutral. Good enough, we've met it in one of our questions in this exam focus review, right? Sodium chloride is a neutral solution because that salt in solution is neutral because it is obtained from strong base and strong acid. Are you getting me right? Potassium hydrogen tetraoxosulfate 6. This guy is acidic salt. Acidic salt because of this hydrogen in it. Are you following right? And acid changes blue litmus paper to red, not red to blue. So this is not the answer. C, sodium trioxocarbonate 5. This could have. That was why, thank God, I saw that thing was carbonate 5. Please take note, there is nothing like carbonate 5. The trioxocarbonates are carbonate 4, not carbonate 5. So even this compound as it is completely wrong. There is no such salt like that. Are you getting me right? Now we have potassium trioxocarbonate 4. And of course, this potassium trioxocarbonate 4 is the correct answer. Why? This salt, look at it. K2CO3. That's the salt. This salt is basic. In solution, it is basic. Are you following right? In solution is basic. And because it is basic, it changes red litmus paper to blue. Why is the solution of potassium trioxocarbonate 4 basic? So K2CO3 in solution is basic because it is formed from strong acid, from strong base and weak acid. Let me use plus. It is formed from strong base plus weak acid. In fact, let me show you this. What formed this guy is potassium hydroxide plus H2CO3 hydrocarbonic acid, which is a weak acid. Okay? So when this reacts, you're going to get K2CO3 plus water. So this guy is basic because this base is strong base and this is weak acid. So when they fight, if I balance this should be 2 and then this should be 2. When this strong base fights with this weak acid, because the base is strong, it will overpower. So the salt that is formed, its solution will be basic. And therefore, it will change red litmus paper to what? Blue. The correct answer is this option D. So that is it. That is it. And I hope you learned something great from this class. You are welcome. Thank you for joining the class. Remember to share this video to your friends, okay? Yeah. Share these videos to your friend in other schools. Those in school, share it to them. Invite them to join us. So we can guide them within these few months, right? 1 to 2, in fact, less than 2 months to your exams, right? Okay? JAMB and WAEC, it's just ringing at the corner. Since last year, September, I've been singing this. And now we are just very close to the exam. Make sure you are always available. Henry Maduabuchi, thank you for appreciating the effort I've displayed by imparting this knowledge to you, friends. You are highly welcome to have joined the class. So, we'll be meeting next. Please let me say publicly that our physics class will no longer hold today. I was supposed to hold physics class with you guys, right? We're supposed to have chemistry, physics, and English. Physics will not hold. There are 2 reasons for that. One, we'll spend some quality time on chemistry, finishing as much as a lot of things you should know in acid, base, and salt. And then secondly, the topic I am meant to review with you as per the exam course review for WAEC and JAMB, it's on simple harmonic motion. I have actually reviewed that in live session classes, especially for my the GMAETS 4100 level students in various schools. So this is what is going to happen. I will drop the link. I'll send the link to our WhatsApp, JAMB WhatsApp group so that you take it. Okay? As you're taking it, it will be like live, but I will not be active at the moment. Do you get that right? I won't. Just click on it and you start taking it because the video lesson is already available, which means we'll be preparing for English. However, again, we won't take English language today, which means we're only taking this chemistry, which I've concluded. We are going to hold the English class tomorrow. Remember, we have consonant sounds to review after our physical class we had on Wednesday. Tomorrow, we are going to deal with the questions that Group 1 of Art class provided. Are you following, right? There are about 10 to 20 questions that Group 1 of Art class provided. So tomorrow, by the hour of, it's going to be in the, anyway, I'll discuss the time with you guys. I'll discuss, let me not say anything because I have my Bible study activity tomorrow, my worship activity. I don't joke with that. Yeah, I don't joke with that at all. So I'm going to post the information either this evening in our WhatsApp group, JAMB WhatsApp group, or tomorrow in our JAMB WhatsApp group of when the time would be. However, it won't be in the morning. It will not be in the afternoon. Are you following? It will be towards evening. So bear that in mind and do have a wonderful time. Always remember, take your studies seriously. Make your parents and sponsors proud by preparing well to smash high points in your JAMB. And those going for WAEC, of course, ensuring that you arrange your A's parallel, okay? That you arrange your A's, at least in your core subject. If you're a science student, your physics, your chemistry, your maths, your English, your biology, right? Okay? Make sure you blast them A's. They give you strong edge as you seek for your admission after your JAMB. Do have a wonderful weekend, please. Remember to share this video and tell your friends to come and subscribe to the channel and also become a channel member. Bye-bye. Extend my regards to your household and greet your parents, especially for GMAETS 41. Of course, your parents and sponsors as well too. Okay? Extend my humble regards to them for all of their efforts in ensuring that they make provisions for you to learn, no matter the difficulty. Respect.